Guten Morgen. German. It's German. It kind of just sounds like English with a thick accent, which makes sense because English is also a Germanic language. They have different genders for words, just like most other languages do other than English, except they have masculine words, they have feminine words, and they have neutral. There's a third case. I don't know. Masculine and feminine words don't click for me because I speak English and we don't use them. But okay, so check it out. We need to catch back up because it's hard to leave a proof hanging and not finish it or stop talking about it mid-proof. Yesterday, we were given this lovely thing with parallel sides and congruent sides. Awesome. We have this diagonal, and this always seems like a wonky step, but in doing this, we almost finish our proof. Carson, if we're looking at this, why do I claim that angle 1 and 2 are the same? And I'm going to mark it now that I've done it. Why do I think this is true?
Opposite exterior.
So love where your head's at. Don't love the word opposite, but here's our picture without all the other stuff. And I'm claiming this angle and this angle are the same. Are they exterior or interior? Okay, so we have a struggle here. When we're talking about that, like you're wrong, just so you know, but that's okay. When we say interior or exterior, was that rude just for the... Was it? There was zero supposed to be rude. I thought I handled that tactfully, which just means like gently and nicely.
I think it's just very hard to tell someone they're wrong without.
Terrible answer. Here we... Just kidding. It's fine. When we say interior or exterior, we're always regarding these two lines. Are these angles inside the region between them or outside? They're inside. Are they on the same side or on alternate? You said opposite, but I like where your head's at. Good. These are alternate interior angles in this picture. This is the same picture. I just haven't put on these other pieces here. So we know that angles 1 and 2 are indeed the same because they are alternate interior. Awesome. Now, once we have that, remind me, up to this point, we have one triangle shortcut for congruence. And don't talk back, but what is it? SAS. See the joke there? Okay. All right. Do we have enough to use side angle side congruence? Do we have two sides and the angle between them on both triangles? Okay, there is not a right or a wrong. Raylene, what? Raylene, what triangle would you like me to write first? Which one? Alpha, Bravo, Charlie? I'm fine with that. Triangle, Alpha, Bravo, Charlie. How do I make sure, Ashley, that this aligns with the other one? How do I, like, once I commit to A, B, C, I'm okay with that. What's the other triangle that I need to write? Because the order matters. A, D, C. So let's check. If we go through A, B, C, Bravo, because that's how we started. Do you agree I go across one dash and then none? How do, on this triangle, the other one, how do I go across one dash and then none? If I go AC, did I go across one dash to start? Or did I go across the double dash? So I need to go across one instead. So I can't start there. If I go DC, I go one and then two, right? But I was supposed to go one and none. CAD, I go two and none. Hey, look at that. We got it, though. One and then none. CDA. Now, in my mind, as I'm looking at it, I almost think about separating these two triangles just a skosh. So I know that angle A is what's going to match up with this one down here. But it's weird just because you were forced to answer it a specific way. You got there. That's a good sign. CDA, I think, is what we're going to use. Does that look good to everybody? You say no? Okay, cool. How do I know these are the same? Side angle, side congruence. And we have it. Now, remember, we had one little follow-up statement, or I guess we had two theorems. I'm not just trying to show triangles are congruent here. Like, that's not my goal. My goal is to show that specific parts are the same. Now, for this, our similarity statement, or our congruent statement, rather, the reason that we focus so much on order is because it becomes immediately clear. I'm trying to show that angle B, which is the middle, is the same as what? Which is the middle. Now, my suggestion, it's always going to be hard to do. If you think you're at the end of your proof, people naturally want to just put this right here and just like not even think about it. It's like, we're done, here it is. My suggestion is once you do this, like you should have in mind what you're trying to prove. So like I know it's angle B, but I would look at the work and say B and D, and then I can confirm that that's what it was supposed to be after the fact, just to make sure that I'm not just blindly putting the answer without the correct stuff written. Angle B is most certainly congruent to angle D as in delta. And how on earth do we know that, considering that these are congruent triangles? If they're both in the middle, it's like those places correspond to each other, right? And what do we know about corresponding parts of congruent triangles? Corresponding parts of congruent triangles are congruent. Okay, I normally end this with a box in the bottom. Instead, I've written QED, Latin for what? Quad, erat, demonstrandum. Got it. Awesome. Cool. Easy to prove. Ish. Feels good, feels bad. Where would you guys put it? That's a weird one because everybody might say bad. I hate proofs. That's okay. About understanding. Not necessarily can you do it on your own, but with what we did on the board. 5 says, yep, I can follow it. Don't care if you can do it at home alone right now or not. 5, I could follow everything you did, Holloway. 0, what day is it and what year is it? And anywhere in between. Where would you put that? Just for the record, if you give me this, I don't know if you give me 0 or 3. Or 3. I mean 0, right? Like I don't know. Okay, cool. We'll get more practice. Does it feel as hard as it did in chapter 2 when we first saw them? Like it'll start to feel easier or not. Like I can't tell you how you feel about stuff, but let's keep kicking. We have side angle side, and we have corresponding parts of congruent triangles are congruent. This next one, so we're at 4.3, 4.4. We get the second half of stuff. So we're doing triangle congruence. Side angle side works. We use it all the time. As we get kicking, the second half of this same section, and again, same section, we're still in 4.3. We have, I'm going to leave a shorthand. I'm going to write the shorthand first, and then we'll rearrange it. I'll tell you, it's going to be SSS. What do you think this is shorthand for? SAS is side angle side. Side, side, side. Check it out. We have it. Side, side, side. Congruence. Now, SAS is what I will typically use here. Is how I refer to this one. It's just SSS. That's it. Now, as we go through this stuff, this one's weird because historically, every other book that I've ever taught of and every bit of geometry that I've done presented this as a postulate. For whatever reason, probably because we can look for congruence transformations, this year, these new textbooks, which do a pretty good job most of the time, they present this as a theorem. I'm not convinced it's a theorem, just for the record. We can make it feel like one, and we'll treat it as such, and we might actually try to prove it to see if it really is a theorem. But yesterday, when I gave you the markers and I said, hey, here's these specific side lengths, make me multiple triangles, could you? I don't think so. I think no matter what, you're going to wind up drawing the exact same triangle. Like it has to be that way. So hence the postulate part. However, I'm going to follow your book here, and we're going to use this as theorem 4.5. And I'm simply going to write SSS congruence. Side, side, side. That's it. Now, for our theorem, I'll just tell you, I'm going to write it out in words. I don't think we need all the words. So I'm going to talk it out, speak it out, rather, in words. And then we're going to draw a picture, a specific picture, to see if we can't maybe prove it. Okay. I'm going to tell you the wordy version before we have to write it. I'm taking participation if you do, but your call. It's 1 point. Like, it won't kill you. Okay, check it out. I'm going to call on you while you're walking out too. If 3 sides of one triangle are congruent to 3 sides of another, then those triangles must be congruent. Like there's nothing to it, right? Now, to make sense of this, here's what I think we should do. We're going to sketch a picture, but I'm going to sketch a very specific picture. Okay, we need side, side, side congruence. Now, I'm not going to be like crazy about making it perfectly to scale, but I'll try to make it at least kind of believable. So let's say we have this lovely thing, and I'm trying to make it believable again. So we'll go there, and we'll go there, and I don't know why I'm doing this in like the most roundabout way, but it's beautiful. There it is. I'll scooch over just a little bit. I can't. All right, we'll copy and paste over just a little bit. Get out of here. What? Get out of here. What? Okay. I'm just going to redraw it. Easy enough. All right, check it out. It's awesome. Here's, I don't remember what the picture looked like before. Something like this, right? Close enough? Okay. This one's going to be a little bit weird, but we're going to use this picture for the theorem. Let's call this one L, M, and then here's where it gets weird. This point happens to be on both triangles, right? Now, I'm going to pretend as though that wasn't necessarily the case, and we'll talk about what I mean by that. But let's say this point on this triangle is LMR, and then we'll switch it over here, and I suppose we can do the same thing. Let's say that this is QVR, and I don't mind calling that the same point. Now, what I was apprehensive about doing with this is when your book presents it, they really like to use that idea of the rigid transform stuff. If I had 2 triangles, and I'm about to, okay, if I have these 2 triangles, and they happen to be lined up like this, do they look congruent to you? Now, all that we've done in this picture, and I know that it's not the exact same, is can we imagine that I'm going to translate this one up so it does this? So whether we call that point R and then some other point, eventually it become the same. And I could move that to become the same. Okay, so for this, I did not mean to drop it, but let's jump in. If I give us this picture, what do you think we're trying to show? Given this, and I guess we're going to need some stuff, what are my assumptions, the given stuff that I need to be able to mark? If what is true about these? All the sides are the same. So let's go ahead and we're going to prove this. For this picture, we want to be given all this and show that it, in the end, implies and the triangles are similar, or congruent, rather. So let's see. What side is the same as LR? It can be RQ or it can be RV. Okay, we're just doing this purely arbitrarily. We just need to make sure all 3 sides are the same, which means QR looks like it's probably going to be the same as this one. And then you have a choice here, and I don't care which one you use. You could use 3 like this, but I think it gets gross and ugly. Anybody recall how I do the 3rd one? Okay, boom. I just do a dash with a dash on it instead of doing 3. It gets too ugly in my mind. You can use the dash or the 3 dashes if you'd rather. Okay, if I give you all this, I want you to help me show that triangle, and I'm going to pick the first one, MRL. We want to be able to show that, and what this theorem says, is that if you get this, then triangle MRL would be the same as what? VRQ. So be really careful. We're going to clean this up. Do you know what you have to do to be good at something? Like, what's the first step to being good at something? Well, that's the second step. Being bad at something is always the first step. Like, nobody's good at anything naturally. But check it out. We're going to clean it up right now. If I write MRL, Ashley, I'm going to start at M, right? Now, how would you describe which segment I just went across to get here? Good. How about with the marks that we have in our picture? Do you agree we just went 2 dash? So when I do this, I go 2 dash, and then if I go to L, I go over 1 dash. Like, you're cool with that. 2, then 1. And I wouldn't write an ordered pair, like that could be confusing. If I want to go across 2 and then 1 on this triangle, where should I start? I have to start at Q, and if I want to go across 2, is it to V or is it to R? To R and then across 1 to V. And that's it. Every time we're going to do that, we have to be careful with it. And I'd rather you get it wrong and be aware that you're getting it wrong than feel completely confident and get it wrong over and over, because it will kill your proof. Q, R, V. Okay, so this is what our theorem says. This is a picture of it. 3 sides the same means that the triangles are the same. Now, our goal is to try to prove this. Our given stuff is all this assumption. We are given 3 sides congruent. So we're going to start here. We're actually going to prove this as a theorem, although I'm not convinced entirely that it is a theorem. It's going to be super easy to prove as long as we talked about stuff yesterday. So here we go. We're going to prove this. This is what we're trying to prove, or our show statement. How do we always start proofs? Given. What are we given on this picture? So I don't think we've talked about any angles. Okay, so check it out. ML, I believe, is congruent to QV, or VQ, however you want to write it. I would probably do, if we did ML, sorry, I'd probably do QV. Give me another pair of congruent sides. LR, and that is congruent to what? VR, cool. And one more. QR, Camille, is congruent to what? Good, MR. Okay, there's all of our given. Now, that is like the if part of our theorem. Now, I didn't write it in words because I don't think we need it. If we do, I can write them. If 3 sides are congruent on both triangles, then the triangles are congruent. We're already written down that all 3 sides are congruent. Now, the benefit to drawing it in this fashion is super helpful, especially the way we constructed it. I think that there's a relationship that exists here that I can use to my advantage. Because what's the only shortcut that we have for proving that triangles are congruent to each other? SAS. Unfortunately, I don't have any angles right now. I can't say anything about these angles, that would be alternate interior, unless I knew that these were parallel, which I didn't. They might look like it, but I can't use that. Is there any chance of finding a pair of angles that you are certain are congruent? LRM, I'm going to call that angle 1, just to simplify. Here's angle 1. What is the same as angle 1 and Y? So it's obviously going to be angle 2. Where would angle 2 live, though? VRQ. Why here? So that's a weird way to ask it. Why are these congruent is a better question. Angle 1 is congruent to angle 2. They're vertical. We get to use that with an AL, not CLE. Vertical angles. Anybody's proof senses tingling yet? If they're not yet, check it out. I'm just going to ask you again, what's the only shortcut that we have? And I don't want you to erase anything, but I'm just going to pretend like this side, I just don't know anything about it. Do I have 2 sides of one triangle congruent to 2 sides of another? Is the angle between those sides also congruent? So what do we conclude? Yeah, the triangles are congruent. Like, it's done already. There's nothing here, nothing crazy. Once we recognize that we have a pair of angles, we can suggest or write that MRL is indeed congruent to 2 then 1, and we'll go QRV. Triangle QRV. And one more time, Ray, you gave me the statement, or the justification rather than the statement. What was your justification? Side angle, side congruence. And we're done. Piece of cake. All right. Now, as we go through stuff, I'm going to put a couple examples up, and we don't even have to draw them. We are going to have time to work in class today. I'm giving you a bunch of time. Fifth hour does not get a bunch of time because they only have half of the class, which this works out perfectly for you, less so for them. Okay, you do not have to draw these unless you're just dying to. I probably need to have this guy. All right, here's my question for you, and we can read the directions. I want us to decide if on A, whether or not these two triangles are congruent. You're going to help me write the congruent statement. I just want to know, are they congruent and why? It's not a proof. On this one, can we say that there are congruent triangles here or not? Talk with your neighbors. I'm going to pause it. We're going to talk about A and B. We'll go like 30 seconds. Can we say definitively, meaning for sure, if there are or aren't congruent triangles on A? Just these two. Okay, for this, we have two sides that are congruent, 1 and 2 and 1 and 2. And if I'm going to use side angle side, the order matters. I have to be able to go from a side to an angle and then immediately to a side. Does it happen? These are congruent. I'm going to write it out here. Ashley, I'm going to call on you to be confrontational. What's the same as triangle SUT? SUT. XZY, fantastic. We got that bug worked out. All right, this one, we're going to clean it up. And I might have made this comment yesterday, but I want you to remember it. Do I swear in my everyday life, do you think? I speak like a sailor. When my kid's not around, sailors, by the way, are notoriously foul-mouthed, if you didn't know that. The day that I stopped dropping like really bad words is that and I replaced the worst words that you could say with like golly or gosh is the day that Zeke started saying golly and gosh when I said it. So the timing was perfect. Check it out. I try not to swear. I pretty much never swear in school. Just I don't. Or at home anymore. So maybe I don't really swear. And Ashley won. But check this out. If I follow the order, I can go from an angle, and then what's the next mark I would hit? I wouldn't go here because I'd skip something. So angle, and then I get a side and a... Now, if I try to go side, angle, side, I just can't do it. I could go from side to, there's no marked angle here or no marked angle here, so I can't get to another angle. I can't go side, side to the third side because nothing's marked. Here's the thing that I want you to internalize. This is not a triangle shortcut. Okay, for this, if you are offended, I'm terribly sorry. But if you try to use this shortcut, I want to make very sure and very clear that afterward you should feel like an ass. Why? It does, but there's a reason, because you're going to remember it, I think, because you've probably never heard me swear before. Why on earth would I say that? Because it's angle, side, side. That's the order that it shows up in. This is not a shortcut for us. People will try to use it. You can't. Does not exist. We will not use it. Cool. With that said, are these triangles congruent? No, because angle, side, side. Cool. That's it. All right. Feel all right with that? Baller. Well, we get a lot of time, 15 minutes. I hope you don't have homework, but we'll see how it shakes out. So that is the end of the lesson. What are the two triangle shortcuts that we have so far, real quick? Love it. That's what? Side, 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 because it's nothing but S's. And the other one? Side, angle, side. Which one doesn't exist? You get one pass. Deal. I'm telling all your parents. All right. Purely, it's really none of my business, and you don't have to answer. Do you guys swear at home? Are you comfortable to swear around your parents?
No. I'm pretty sure I'd get beat to a pulp.
I hope that's exaggerated.
It is.
Good. Good. All right.
We're not allowed to say curse words until 18. We're not around the parents.
Good. Well, I hope that I didn't just hurt your ears by saying inevitably the first foul, profane word you ever heard. V-Dog.
Oh, it's my sister's full.
I just heard you guys wish for a pop quiz.
No.
Pretty sure. All right. Okay, anywho, here we go. Homework. We're going to call this 4.3. And you will find 4.3 waiting lovingly on page. We're going to start on 173. The problems, it's going to seem like a long assignment, but remember the last two problems that we did that took like 2 seconds and all you had to do was say yes or no with SAS or SSS? Cool. Remember those. You're going to begin with 6 through at least 11. You're going to start at number 6. And you're going to go through number 12 initially. I like some of these higher order thinking questions. Ooh, 16. How many proofs do you want?
1.
I can't split the difference between those. Let's do 19. That one's not a proof. But I'll find it. Okay, 21 is not a proof formally, but it does say explain. So if you wanted to do it like a proof, you'd be in the right situation. When it says just explain, you don't have to formally prove it, but every part of your explanation would show up on the proof, just so you guys are aware. Cool. That's it. That's all I got. Do 11, 12. Do it today, but I will collect it tomorrow. Baller. All right. Andrew, if you're watching this, please stand up. If you make a reference to this, I will give you candy. Because Eminem is the reference there. Okay.